Okay, so in this video, let us look at the table that I had sent you on WhatsApp. So you can just open that on your phones. Yeah, so here I have the list of the elements: hydrogen, helium, lithium, beryllium, all of that up to atomic number 18, and listed in the last column here is the valency of those atoms. So if we look at hydrogen has a valency of 1. So they are not given the sign, but that doesn't matter, right? Really. And yeah, so here hydrogen has a valency of 1, which means hydrogen would want an electron, and if it gets that electron, it will be stable. Helium has a valency of 0, which means it is already stable, it doesn't need any more electrons. Lithium has a valency of 1, which means it would want to give an electron to become stable, and so on and so forth. Now in this video, what I'll like to show you is that if we have a look at the various metals and non-metals, so this is just a basic classification that I'm trying to show here. So if I write metals here, so you know what metals are, right? Here I write the metals, and here I just write the non-metals. So metals include, so let me just look at the list here and write the metals and non-metals here. So lithium is a metal. If I go on further, I can see that I have another metal, sodium. I have magnesium. I also have aluminium, and yeah, I think that's it. Yeah, I believe those many are enough. And if I look out for some non-metals, well, the clear ones are nitrogen, oxygen, fluorine, and let's say I'll just take chlorine. I believe those many are enough. Yeah, there are many more in the list, but I'll stick to these many. Now if I look at the atomic structure of all of them here in the table, so you can look at the table. So obviously it is only the outermost shell that really matters, because the valency of any particular atom depends on the number of electrons in its outermost shell, and because by that number you can find the number of electrons it wants to attain to be able to have 8 electrons in its outermost shell. Yeah, so here if we look at the outermost shell of lithium has only 1 electron in its outermost shell. So here in its outermost shell it has only 1 electron. Sodium, if we go to sodium has 1 electron again in its outermost shell. Magnesium has 2 electrons in its outermost shell. Aluminium has 3 electrons. Nitrogen, if we find here, has 5 electrons in its outermost shell. So this is something that even you can look up in the table and it will make things clearer. Oxygen here has 6 electrons in its outermost shell. Next is fluorine. Fluorine has 7 electrons, and chlorine lastly has again 7 electrons in its outermost orbit or shell. And now if you try to figure out the valencies of all of them, we can clearly see that lithium would really want to give away this electron, 1 electron, to achieve it to achieve 2 electrons in its outermost shell, because yeah, so to achieve the completely filled outermost orbit, outermost shell, so its valency would be simply +1, because it would want to give that electron. Again, sodium would want to get rid of this 1 electron. We've seen that in the previous videos, so its valency is +1. it would want to give away that electron. Similarly, it's easy for magnesium to give away those 2 electrons rather than get 6 electrons to form 2 plus 6, 8 electrons. So it will simply want to give this 2 electrons away. Similarly, aluminum would also prefer giving 3 electrons. But in some cases we can observe that it also tries to gain 5 electrons, but let's leave that away. We'll focus on the plus 3 valency of aluminum. Here nitrogen has 5 electrons. Now should it give those 5 electrons? But so actually nitrogen would really want to actually get 3 electrons. So 5 plus 3 is 8, so it would just simply want 3 electrons, and if it gets those 3 electrons it would achieve 8 electrons. So instead of giving those 5 electrons away, it would simply get 3 electrons, and if it wants to gain 3 electrons, it has a valency of -3 because it lacks 3 electrons. Similarly, oxygen doesn't want to give those 6 electrons away. It would simply take 2 electrons, so 2 plus 6 would become 8, and so it would really want 2 electrons, and therefore its valency is -2. Now fluorine has 7 electrons, and obviously giving 7 electrons is very tough. It is better to just get 1 electron, and it just wants 1 electron, and so it has a -1 valency. Similarly, chlorine also would just gain 1 electron, giving it a valency of -1 rather than giving 7 electrons away. Now if you look at the general trend here, we can see that metals generally have a positive valency, +1, +1, +2, +3. On the other hand, non-metals have generally a negative valency, -3, -2, -1, -1. So if we have the ions of both metals and non-metals, if you look at the ions of them, the ion of a lithium, so a lithium ion, how would we form a lithium ion? Well, we would form it by giving an electron away, which means that the ion would have a net positive charge. It has given an electron, it has 1 extra proton left, so that lithium ion has a net positive charge. Similarly, sodium would also be a positively charged ion because it has given an electron. Magnesium would have an ion that has a +2 charge because it has given 2 electrons, and aluminum would have an ion which would have a +3 charge because it has given 3 electrons. So what we see is that these metals have a positively charged, I'll just write it as positively charged ion, So metals generally have a positively charged ion, and we've just given a name to such positively charged ion, which is simply cation. So cation is nothing but a positively charged ion. Simple, right? Similarly, nitrogen would have to gain 3 electrons, which means it gains a negative charge due to those extra 3 electrons. So the nitrogen ion would have a charge of -3. Oxygen ion would have a charge of -2, fluorine ion -1, chlorine ion -1. So generally we see that non-metals have a negatively charged ion, and we are again given a name to such negatively charged ions. I hope that is clear. Yeah, and we simply call such negatively charged ions anion. So an anion, I hope that is clear, is nothing but a negatively charged ion. So anion is negatively charged ion, cation is a positively charged ion. A simple trick to remember that, well, you can always imagine that cats are a positive kind of pets. Whenever you are around cats, you feel positive, and so cat ions are positively charged. On the other hand, anion sort of sounds like anion, onion. I don't know why, it just looks to me like an onion. It's just a difference of an A. So and onions are kind of negative because if you cut onions, they make you cry, so they're negative. So that is a trick to make us to just remember that anions are negatively charged and cations are positively charged. You can obviously come up with your own tricks to remember such things. But yeah, that is the basic idea of cations and anions, and we've seen that metals generally have a positive valency, and therefore metals generally form cations, whereas non-metals have negative valencies and thus generally form anions. So yeah, that is it for this video.